Now let's take a look at multiplying rational expressions. So when you multiply rational expressions, step 1 is you can multiply the numerators. Step 2, then you multiply the denominators. Step 3, you write the new fraction in simplified form. And then name the excluded values is really important. Now the property that we can take a look at is if you have A over B times C over D, then it says to multiply AC, then it's AC over BD, and then you need to simplify if possible. So that's the property. And then B or D cannot be 0 because it makes the denominator 0, right? So B cannot be 0, D cannot be 0. So here is an example. So there's a couple ways to do this problem. As if you want, you can kind of start canceling out here, reducing if you want, but sometimes it gets a little messy because there's a lot of information here. And so what we're going to do is we're going to go ahead and multiply this through. And I'm going to kind of factor as we go. So 5x squared, I'm going to say this is 5 times x, and then the 6 is 2 times 3, right? 6 is 2 times 3, and then x times y over 2x, y times 5 times 2 times y. So that's one way you could approach the problem, is break it all down. So that I'm going to do that first. And so we can cancel out our common values in the numerator and denominator, so divide them out. So 5's cancel out, 1, 2 canceled out on the top and the bottom. Then we have 3 y's here, 1, 2, 3, and there's 1, 2, 3 down here. We have one more x we can cancel out. And then I think that's about it. So we can write what's left over. So we have 2 x's and a 3, so 3x squared over 2. Now the other thing we need to mention is what we cannot have, our excluded value. So notice that we had an x and the y in the denominator, so make sure that you write that x cannot be 0 and y also cannot be 0 here. So that's one way to approach this problem. Of course, you have to name these excluded values. Another way to do it is working from this problem here, that you can say, well, 5 goes into 10 2 times, and then you have a y squared and a y here, so you can cancel that out here. So y squared and y is 3y, so that cancels out. And then 2 goes into 6 3 times. And then we have a single x here, so that cancels out, and you have an x here. And then now you just write what's left. So the x squared and the 3, and then nothing else in the denominator. That's a second way to do it. Now, the third way to do it is go ahead and multiply all the way through. So we can say 5 times 6 is 30, and then x, we have an x squared and x to the first, so x cubed, y cubed over 2 times 10 is 20, x, y to the third. So that's another way to approach this problem. And actually, from the looks of it, it looks kind of nice, right? So the y cubes cancel. We know the 3 and the 3 and the 0 cancel here, and so we're left with 3 and 2. Well, you divide out a 10 in the numerator and denominator, and then this x becomes an x squared. And so notice you still get the same answer of 3x squared over 2. I apologize in the other one, that should have been a 2 down there, okay, just like this one. So those are a couple ways to approach it. And so let's try example 2, find the product, and then example 3, that's factoring and then finding the product. No, it's just simplifying, right? So let's try this example here. I'm going to go ahead and cancel things out from where we are. So 4 goes into 8 2 times, and then 2 goes into 2 1 time, right? So we can keep on doing this. So now that's just 1. Let's go ahead and multiply what's left. So I have 1 x cubed, let's see, we have 7 x cubed and x to the 4th, that becomes x to the 7th. They have y and y cubed, so that becomes y to the 4th, over x, and then we have y squared and y cubed. So let's simplify. That's 7, so x to the 7th over x, that means I only left with a single x, well, I'm left with x to the 6th, right? You subtract the exponents. And then it is y to the 1st. And so that is the product. So really, it says product, but really we're just simplifying, and so just kind of look at it in that sense. And remember to name your restrictions. So here, remember that x cannot be 0 and y also cannot be 0. So example 3, we're going to find the product. Now this is a little more complicated here, so we're going to do this one together. So notice you have 3x minus 3x squared, and so what I want to do is I want the x squared to be in front, but I want it to be positive. So what I'm going to do and I'll do it over here on the side. 3x minus 3x squared. I'm going to divide by negative 3x. And so what this becomes, it becomes 3x minus 3x is negative 1, and negative 3x squared over negative 3x is a positive x. And then remember that we factored out the negative 3x, so that's here. So I want to rewrite this where the x is in front. So I'm going to say negative 3x times x minus 1. So negative 1 plus x is the same thing as x minus 1. I just moved the order around. So this negative 3x times x minus 1 is this same thing here. We just did a lot of rewriting for it. And so I'm going to replace that here. Negative 3x times x minus 1. And then we need to factor the denominator here. So let's do that. X squared plus 4x minus 5, that's what I need to factor. And so if you need to do the x method, you can, but hopefully, at some point you may be able to move away from that. So this is 5 times negative 1. So the denominator factors to x plus 5 times x minus 1. Then this one here, again, if you need the x, we'll multiply to negative 20, that adds to 1. That's going to be 5 and a negative 4. So this is going to be x plus 5 times x minus 4 all over our 3x that's right here. Okay, so lots of factoring. Now we're going to cancel out our common factors. And so we're going to cancel out this 3x and 3x. Remember that there's a negative 1 here, though, so we need to make sure that still exists. And then the x minus 1 cancels. And then also our x plus 5 and x plus 5 cancels. Now looking at this currently, let's look at our restrictions because I don't want to forget that. Let's take a look. We know that down here we cannot have zeros in all of these places here. So let's write it. X cannot equal negative 5. X minus 1 means I can't have a 1. And I also can't 3 times x. That also cannot be a 0. So those are my restrictions. Then let's write what's left over. So what's left over is we have the negative here, and then we also have an x minus 4. So we have a negative times x minus 4. So now this is done. And then there is the restrictions. X cannot equal negative 5, 1, and 0. So you need to try, or you should try, these two below, 5 and 6, and then I'll have the answers for you in a minute. So trying these out below, you should have gotten x squared times y squared over 4. X cannot be 0, y cannot be 0. And for number 8, if you factor that all out, you should get that x cannot equal 5 and negative 5 and 0. The numerator would end up being x plus 3 over x times x plus 5.